right, ladies and gentlemen, welcome to your first video for pre-algebra. Couple little pieces of information before we get started. Please, please, please make sure that you are paying close attention to where I tell you to put things. If I say put it on page 6, make sure you put it on page 6. If I tell you to go to page 7 to start some examples, even if you have room on page 6, I need you to go to page 7, or else your notebook is going to be completely messed up. I encourage you to use highlighters, different colored pens. It can help make your note-taking easier. Also, please make sure if you need to pause the video, re-watch the video, take some extra time to write the notes down, do so. That's the beauty of having the lesson on video. You can take as long as you need to understand the concept. That being said, I'm going to move very quickly through this video, so keep up or pause if you can't keep up, all right? So what I need you to do is on the top of page 4, you're going to write the page number and the date, like you need to have on every single page in your notebook. I also need you to put the title, which for today is Properties of Numbers. Please make sure that your date and page number are on the outside corner. That's going to make it easier for us to find your pages. If they're over by the spirals, it makes it harder to find. Our objective for the lesson today is for each of you to be able to say, I can recognize the different properties of numbers and can use them to simplify expressions. This is something that people really struggled with on the pre-test, so we need to make sure we know how to do it. With the remainder of your page, after you write the objective, I want you to take the rest of the page and divide it in half, okay? The first half, you can put a little label over here to the left of the red line, is going to be additive identity. And we're going to use that section of the page to take some notes on additive identity. The next one is going to be additive inverse. So please take a moment to label that. When you're ready, if you need to pause, you're more than welcome to. When you're ready, just hit start again and we'll move on to the next page. In the additive identity section of your page, remember we are still on page 4, you need to jot down some notes about the additive identity, and I'm going to explain some things in words, in symbols, and then I'm going to give you an example. So, the additive identity in words. For any number, A, the sum of A and 0 is A. I know math definitions can be crazy. Write it down. The symbols and the examples will help make it make more sense. This is something you all already know, I promise. If you write it in symbols, you will have A plus 0 equals 0 plus A equals A. That's just what it says here. For any number A, the sum, that's addition, of A and 0 is A, right there. Okay, that is the additive identity. Some examples, this is stuff you guys know, 2 plus 0 equals 2, or 0 plus 2 equals 2. The problem that all of you run into is remembering that that is called the additive identity. It's not good enough to know you can add 0 to any number and the number stays the same. You need to know what it is called because you are expected to know that. Moving on. The additive inverse. Once again, I'm going to show you in words, in symbols, examples. Pause at any point, rewind at any point if I get too far ahead of you. In words, the additive inverse is the fact that a number A and its opposite are additive inverses of each other. Additive inverses add up to equal 0. This is important. It's something that's going to become really important when we get to the integer unit. Okay? In symbols, we simply have A plus negative A equals 0. An example of that with numbers, 3 plus negative 3 is 0. They cancel each other out. In class, we talked about the soldiers, the evil soldiers, and the good soldiers. So if I have 3 good soldiers and I have 3 evil soldiers, neither side's going to win the war because they're both going to get canceled out. Okay? All right, moving on. I would like you to please start a new page in your notebook. This is going to be page 5. Make sure you are using the fronts and the backs of every page in your notebook, or else you are going to run out way too fast. For this one, at the top of the page, I want you to write properties of multiplication. And then the 3 sections, you're going to divide your page into thirds, and the 3 sections are going to be identity, property of 0, these are all for multiplication, and inverse. Okay? Once again, we're going to go through each one. I'm going to show you it in words, in symbols, and then give you an example. In the multiplicative identity section, the definition or the words that I want you to put down, for any number A, the product of A and 1 is A. Don't you love the way they write math definitions? It's crazy. This also is something you already know. You know that any number multiplied by 1 is going to just equal that same number. Once again, you don't remember the fact that it's called the identity, multiplicative identity property. The multiplicative property of 0 is really easy too. Let's go through it very quickly. For any number A, the product of A and 0 is 0. You know this. A times 0 is 0. 0 times anything is 0. Pause for a minute, write it down. Most importantly, take a minute to not just think to yourself, a number times 0 equals 0, but think to yourself, multiplicative property of 0. We need to know that name. Moving on. Told you I was going fast today. Multiplicative inverse. This is probably the one that people have the most difficulty remembering. It was actually the last question on your pretest. It said, what would you multiply 2/3 by to equal 1? I had a handful of people get this question, but not a lot of people. It's the multiplicative inverse property. So here's what it is. For every number A over B, that's just a fraction, a rational number, there is exactly one number, B over A, such that A over B times B over A equals 1. Do not get bogged down in the words. I know they're math speak. We have a fraction here, A over B. We have a fraction here, B over A. When you multiply A over B times B over A, you get 1. In symbols, it looks like that. A real world example, 4/5 times 5/4 equals 1. So to go back to that question that was on the pretest, it said, what do you have to multiply 2/3 by to equal 1? It is simply the multiplicative inverse. So you will flip it, 3 goes on top, 2 goes on bottom, and you end up with 1. And that makes sense. What's 2 times 3, guys? It's 6. What's 3 times 2? It's 6. What does 6 over 6 simplify to equal? That'll give you 1. Okay? Focus on the name of the property, guys. All of this is common sense. You just need to memorize the names. Okay, so let's take a minute here. We're going to go through some practice problems. I want you to be pausing the video so you can really try and figure it out yourself before I give you your answer. Here we go. Which property of multiplication is shown below? We have 6 times 0 equals 0. Pause the video and try and figure it out. You better have paused. If you didn't, I will yell at you. The correct answer is multiplicative property of 0. Answer B. You don't need to write these down in your notebook, guys. I'm not too worried about that. We're just practicing to get the review. Next, which property of multiplication is below? Pause the video, figure it out. And your correct answer is A, multiplicative identity. The identity properties deal with the number 1. What do you multiply -8 by to get the same number? You multiply it by 1. Oopsie, wrong way. Sorry. Question 3, which property of multiplication is below? 1 times 6 equals 6. Pause the video. And your correct answer is A, multiplicative identity. Once again, multiplying by 1 gets you the same value. Which property of multiplication is below? 0 times 10 equals 0. Pause the video. All right, guys, the big hint here is the number 0. We can all figure that one out, I hope. If your brain is turned on, you can figure this out. Which property of multiplication is below? 5/3 times 3/5 equals 1. Pause the video. Your correct answer is multiplicative inverse. 5/3 and 3/5 are inverses of each other. When you multiply them, they equal 1. I'm just going to pop the next few questions up on the screen very quickly because I don't think we need to spend too much time on this. Take a minute. Correct answer is B. Take a minute. Correct answer is C. The correct answer here is A. Don't get confused here. I know there's fractions, and fractions might make you think that it's an inverse, but in reality, it is being multiplied by 1. That means it is the identity property. Take a minute. There's that 0, multiplicative property of 0. Last one. We have 2 inverses there. We have 6/1 and 1/6. That means it is the multiplicative inverse. All right, so those are the properties of multiplication. Now we are going to talk about some other properties. Please go to page 6. Page 6. On page 6, I want you to divide the page into 2 sections. The first section is going to be commutative. The second section is going to be associative. And I want you to think of a couple different words as we're going through the next few notes. For the commutative property, I want you to think commuter. Not computer, commuter. A commuter is somebody who drives back and forth, let's say, to college. In college, you either live on campus or you are a commuter. You drive from home to school and vice versa. So keep that in mind, that word commuter. For the associative property, I want you to keep in mind the word associate or associate. An associate might be somebody that you work with. The people you associate with are the people that you spend the most time with, your group of friends. Just keep those words in mind as we go over our notes. For the commutative property, once again, I'm going to show you in words, in symbols, and an example. The commutative property is simply the order in which you add or multiply numbers does not change their sum or product. I want you to notice this is for adding and multiplying. This is not for subtraction. It is not for division. Commutative property does not work for those two. Maybe in class I'll explain to you why. In symbols, if I have A plus B, it is the same as B plus A. If I have A times B, it is the same as B times A. Many of you know this, you just don't remember the word. I told you on the last screen to remember the word commuter for commutative property. A commuter, remember, is somebody who moves back and forth, who perhaps drives to college and then back. What do these letters do in the commutative property? Guys, they move. The B trades places with the A, and the A trades places with the B. They are commuters. That is how I always remembered it. An example with actual numbers, if you have 4 plus 8, it's the same as 8 plus 4. If you have 7 times 11, it's the same as 11 times 7. 7 times 11 is 77. 11 times 7 is 77. Know the word commuter, commutative. The associative property. In words, the way in which you group three or more numbers when adding or multiplying does not change their sum or product. I will say again, sum and product. If you only have addition, you're good to go. I'm sorry, guys. If you only have multiplication, you're good to go. But if there is any subtraction, if there is any division, you need to be so careful because the associative property doesn't work. In symbols, in this first example, we have A matched up with B, and then C is added on. In the second example, we have B matched up with C, and then A is hanging out here on the side. Remember I told you to use the word associate, which means somebody you hang out with, somebody you work with. In the left side here, A is hanging out with B. The associative property says it's perfectly fine to switch it and have B hang out with C instead of A. Let's take a look at an example in numbers. This first one, 3 plus 5, and then plus 7. What would 3 plus 5 be? Hopefully you said 8. If you add 7 to that, you get 15. Now let's look on this other side using the associative property. We're going to do things in a slightly different order because following PEMDAS, you always do parentheses first. So over here, I'm going to do 5 plus 7, which gives me 12. And then I'm going to add my 3 on. But guess what? I get the exact same number. You guys know this. You've done this. Memorize the words. Distributive property is the last property we are going to talk about today in this video. Distributive property is the one that is probably messed up more than any other property. It's also probably the most important to you going forward into algebra, geometry, algebra 2, and on and on. On page 7, please put the page number, put the date, and your title is going to be distributive property. We are going to start out with a couple definitions. The definition of the distributive property written in fancy math speak is the distributive property is used to multiply a single term and 2 or more terms inside a set of parentheses. A term is really just part of the expression. So if we look down here, we have A multiplied by B plus C. Okay? Be careful. I have a lot of people that still get confused on this. If you have a letter or a number right next to a parentheses, there is a hidden symbol, and that hidden symbol is multiplication. Okay? I always like to think of it as mathematicians are lazy. So they don't want to write the multiplication symbol, but you can't forget that it's there. So in the distributive property, let's ask ourselves a few questions. If I have 6 times 13, what is that going to get me? 78. Let's split up this 13 here, though, into 10 plus 3. And let's see what that does. Let's see if that still gets me 78. So over here, I have my 6 times parentheses 10 plus 3. Using the distributive property, I can take that 6 and distribute it to the 10, distribute it to the 3. Don't forget this multiplication symbol. So 6 times 10, think about what that's going to be. That's 60. Plus, I distributed my 6 to my 3 as well. 6 times 3 is going to be 18. Does that give me 78? Yes, it does. A simple proof of the distributive property. All right, on that same page, I want you to write this. Equivalent expressions. Equivalent expressions are going to become really important when we get into one-step equations, two-step equations, systems of equations, which is all coming down the road. What you need to know is that equivalent expressions have the same value. So if we look down here at this example, the expressions 3 parentheses 2 plus 4 and 3 times 2 plus 3 times 4 are equivalent expressions because they have the same value, 18. This used distributive property. my 3 right here was distributed or passed out or given away to both things inside the parentheses. Because there is no symbol there, we assume it's multiplication. Remember, mathematicians are lazy. So you end up with 3 times 2 and 3 times 4. I found this really fun example that I want to go through with you. We're almost there, guys. Hang tight. So, and a simple example is just passing out homework to everyone in the class. I'm not going to leave somebody out. If I did, you'd be mad at me. So let's talk about a costume party. So far we have one person, Beth, who's dressed up as a bride. We're going to call her B. And another guest comes to the party who's dressed up as a cat, C. So I have at the party so far B plus C. They're both at the party. The parentheses, sorry, the parentheses represent the sides of the house, okay? So B and C are inside the house. They're hanging out together. All of a sudden, you walk in. You are a snowman. Hi, Mr. Snowman. You are going to be represented by the letter S. And you want to make sure to say hi to both the bride and the cat. Otherwise, one of them is going to feel left out. So Mr. Snowman is outside the house. He wants to say hello to both of them. So Snowman says hello to the bride, and Snowman says hello to the cat, represented by this expression here, SB plus SC. Over here, we've got the snowman on the outside. Here, let me use a different marker. The snowman on the outside, the parentheses, which are the house, and then you have B plus C. They are equal, guys. That is the distributive property. But what if another person comes dressed up as a dragon and wants to say hello to everybody? So in the house, in the parentheses, we have the bride, we have the cat, and we have the snowman. And now the dragon's out here outside of the house and wants to say hi to everyone at the party. So the dragon says hi to the bride, the dragon says hi to the cat, and the dragon says hi to the snowman. An example with real numbers. You know what? I'm going to skip that because you already saw something like that. I think you can handle it. Let's take a look at a real-world application. A one-day pass to Six Flags Great Adventure costs $40. A round-trip bus ticket to the park costs $5. So if you want to go, it's going to cost you $45 total, right? But now we want to take 15 students. So we have to find out what that's going to cost us. And we want to find 2 equivalent expressions. So these 15 students are going to need to buy a bus pass, so that's 15 bus passes, and they're going to need to buy 15 passes, 15 one-day passes. So we can put our costs into that equation. We have 15 times B, which is the bus pass, that's 5. And then we have 15 times 40, which is the day pass. All right? But with the distributive property, there's another way to do this, another way to write it. You can say, okay, well, I have 15 people, and each of those people is going to need a bus pass and a park pass. If I put my numbers in there, it's going to be 15 people, each need, whoopsie, a mistake, each need $5 plus $45. And if you were to actually do the math on both of those, put them both in a calculator, you would get the exact same answer. I was going to do more, but I think it would be mean to make a video that was longer than 25 minutes, so I'm going to leave it at that. Please make sure you review the video if you need to, and I will see you on Monday, no, not Monday, Tuesday afternoon, and I will be checking your notebooks, so do the homework. Have a good weekend.